Hello everyone, this is Mal Haddad here again. In this lecture, I'm going to explain about the designated router and the backup designated router. So as you can see here, we have a multi-access segment or a broadcast segment, which means that you have the area 0 here, the backbone area. And inside this backbone area, there are 8 routers, which are all connected to the switch over here. Okay. Say that you have a subnet of 192.168.0.0/24. So this will be having .0.1, 2, 3, and so on. Okay. In this case, when we enable OSPF on each of these routers, we enable OSPF on all the routers. Normally, what we have seen in the previous lecture, that those routers have to form neighborship, and then they will start sharing the updates to be able to form the link state database and then do the SPF calculation, and then the best route will go inside the routing table. Okay, then in this case, if this happens here, then every router has to communicate to every other router. For example, router 1 has to communicate with router 2 and 3 and 4 and 5, 6, 7, 8. Same do on router 2. Then also he has to communicate to all other routers in the network, and so forth. Okay, so here if we want to see the calculation, then it's going to be like n times n minus 1 over 2. N is number of routers, so we have 8 routers over here times 8 minus 1, that means 7 over 2. So 8 times 7, that's 56 over 2. That means we have 28 links. At the end, what will happen, we'll have something like this picture over here. You can see that we have all routers are communicating to all other routers, and we have more like mesh communication between the routers. So here there is a problem because the LSA, as we said, they take a lot of traffic in our network, and they are also multicast. So all those will happen inside our network, and we need to avoid to have that congestion on our network. Now we have 8 routers, but we said in an area we can go really a lot of routers. So if you have like 30, 40, 50 routers, then it's going to be more and more traffic also. In this case, what we can do, we can have a designated router instead, like this picture over here. So what will happen here is, in this case, router 1 will be elected to be a designated router. That means that all the other routers will communicate only to the designated router, which is router 1, okay? And router 1 will send all updates to other routers. For example, if router 8 has a network here which went broken, then he will only send the update to the designated router, which by turn, he has to update all other routers that the network of router A is not available anymore, so they can redo their calculation again, okay? So this is what is the designated router. But also there is another question, is what if the designated router goes off? Then what will happen to our OSPF network? In this case, we will have also a backup designated router. And this is another picture about the backup designated router. As you can see here, router 1 is still the designated router, but router 7 has become the backup designated router. That means that in case the designated router goes off, then the backup designated router will become the designated router. So he will become the designated router, and then all communication of all other routers will happen with router 7. The backup designated router doesn't work unless the designated router goes off. So he's just like sitting and waiting. But all other routers are having a neighborship with the backup designated router. Now, something to mention here. Number 1, that neighborship is formed only between routers and the designated router and the routers and the backup designated router. For example, router 8 will form neighborship with router 1 and will form neighborship with router 7. He will not form a neighborship with router 6, for example. Okay? In this case, router 8 and router 6 will be called DR other. Okay, and they will stay in a two-way state, while here they will be in full state. We will see that when we do the lab in full state, while here it will be on two-way state. Okay, now the question is how the designated router is being elected and the backup designated router is being elected. When we enable OSPF on router 1, for example, and on router 2, okay, first they will form neighborship in case they meet all the requirement to be neighbors, and that's something we've seen it when they share the hello packets, okay. And after that, directly there will be the election of the designated router and the backup designated. I'm just giving router 1 and router 2 to make the example small, but this will apply to all routers over here. So if we enable OSPF on all other routers as well, okay. And then what will happen over here, they will see which one will have to be the designated router. And this is based on something we call the priority, okay. The priority normally is set inside the interface. For example, if we have on this interface is Ethernet 1, then you have a priority, okay? When you have the priority of 0, then this router will not go inside the election of DR. That means that he will never be a DR or a BDR, okay? Now, the router which has the higher priority is the one which will be the designated router. For example, if you have a priority here of 1 or say 10, and here on router 2 is 1, we're still taking this example here, then router 1 will be the designated router. Okay. Now, if the priorities, they tie with each other. For example, we have many routers, and out of these many routers in our network, like this network, 2 have better priority than the others. And both of them, for example, router 1 and router 2, both of them, they have the priority similar. Like this one has a priority of 1 and this one has a priority of 1 also. Then which one will become the designated router? In this case, the one which has the router ID, remember the router ID, that means the name of the router inside the OSPF process. Okay, and remember it should be 4 octets, like we put it for router 1, 1.1.1.1, and we put it for router 2, 2.2.2.2 in the previous lab. So the one which has the higher router ID is the one which becomes the designated router. Then in this case, we said that those 2 routers have the priority which is tied together. Then in this case, router 2 will become the designated router in case he has the router ID of 2.2.2.2. While router 1 will become the backup designated router because he has the router ID of 1.1.1.1. Okay, so this is how normally the designated router and the backup designated router are being elected. Okay, now why do we need to put priority of 0? For example, let me just explain to you also here that again, we are talking about the multi-access network or the broadcast network. That means like we have a switch over here. If you have a point-to-point network, like one router connected to another router, and you have OSPF and you have OSPF, we don't care too much of which one will be the DR and which one will be the BDR, because if this is the DR and this is the BDR, or this is the DR and this one is the BDR, it doesn't really affect too much because we only have 2 routers and it's not a problem. But in a multi-access network like this, that's where it's important to have the DR and the BDR. Another example, I was saying why we need to have priority 0. Also, we can apply the DR and BDR in a non-broadcast multi-access network. For example, in a frame relay. Say you have a company, you have headquarter, you have a router here, and you have another branch office. So this is the headquarter, and this is the branch office number 1, and this is branch office number 2. Okay, so those are branch offices to the main office over here of the headquarters. Okay, in this case, you have, say, all your servers and all your important applications and whatever inside your headquarters. And you want the communication to happen with your headquarters from your branches. In this case, what you can do, when you enable OSPF on all those routers, you can put the priority over here on the branch office to be 0, and also here priority to be 0, while on your headquarters you can leave it, for example, priority 1. In this case, when you enable the OSPF routing protocol, what will happen? Your headquarter will be directly the designated router, and that's what you want because it's the main office and everything has to come to here and from here to there also. Okay, then in this case you can guarantee that your headquarter router is the designated router. So as a summary, a designated router and a backup designated router are mainly used inside the broadcast network or multi-access network and inside the non-broadcast multi-access, like we said, frame relay. And we use them so we can elect one router to be the designated router, and all the communication between the routers will pass through that designated router instead that it's spread from each router to every other router in the network. The backup designated router, it has a function to be as a backup for the designated router, but it only works when the designated router goes off. Okay? And we have seen also that we can play with the priority to elect one router to be the designated router and other to not be designated routers. But in case the priority ties inside the election, then in this case, the router which has the higher router ID will be the designated router. So this is what I wanted to explain to you about the designated router and the backup designated router. Now let's go directly and do the lab and see it on MikroTik how we can configure the designated router and the backup designated router.